Hello, everyone. Once again, my name is Maria Dao, the SC lead at AUB. This workshop is our introduction to data science by PhD candidate Wedad in collaboration with the AUB Computer Science Department. This session will be recorded and we will send a link to the recording afterwards. It will be posted on YouTube if you'd like to check out YouTube channel, the SC AUB. So with that, I'll hand it over to you.
Hello, everyone. So I'm Wedad. I'm a graduate from AUB with Master in Computer Science. And now I'm doing professional doctorate in Engineering of Data Science in TUE, Netherlands. So today we will talk about data science, and this will also include machine learning. So as starting, we will talk about what is data science, the data science process that as data scientists we are using, and what is machine learning, also machine learning techniques. So to start with data science, like its name, data science, like to learn from data, you need to get insight from data. Like you have data, you need to get maybe to solve a problem, but also you need to tell a story from that data. So to be a data scientist, you need to have 3 skills, which is computer science, mathematics, and domain expertise. And if we forget one of those, you will not be computer scientist. You will be doing another thing like machine learning, statistical research, or data processing. Because like if you are a data scientist and you don't know how to code, it will not be data science. Also for mathematics, because most of the modules are running from mathematical formulas. Also, okay, you have coding, you have mathematics, and you are your model, and you're getting output. If you really don't know about the domain you are doing, for example, health or finance, you will not get that insight. You will not be able to tell the story. So data science will be based on the 3 of them. You don't need to be expert on each skill, but you need to have it. So after knowing what is data science, we will go into the data science process. What's each data scientist go from data to output. So to start, it's almost similar to any project you are getting. If you are a programmer or anything, you start with company requirements. You need to ask, what is the problem? You need to define the business behind it, define why you want to solve it. If you don't take time in the first phase, you will not get into what data you want, and you will not get into output. So you need to take time in this phase. Like sometimes you are taking 2 weeks, sometimes it's a month, because you have to do proposal. You have to know and let the stakeholders know what's the problem, because sometimes stakeholders imagine that you are I'm not sure, like we are doing magic. So you need to be sure of what, and then after it you need to get data, relevant data. Sometimes it's from only stakeholders and sometimes it's external. Sometimes you need like social media data. It depends really on the problem, and it depends what do you think the data you are missing. After getting the data and knowing what's the problem, it's now for exploration of the data. You need to clean the data from, for example, empty rows, null values. If you have numeric column, but it should be text. So all this should be exploration. Also, you should include outliers, because for example, if you have all points are gathering on same circle and you have 2 or 3 points are very far from that circle, they are outliers. Maybe they were written error, like added 0 to 1 million. It will be a difference. So you need really to also take time in exploration before modeling, because you don't want your model to act wrongly, and you cannot judge your model if you are getting wrong data and unclean data. So after exploration, you go to modeling. you need to know what technique you will use, because you have many techniques on data science, many techniques machine learning, also deep learning. So you really need to know from your domain what techniques you may use, what time do you have, because some techniques may need 1 month, some 1 week. So you really need to define this. And also this will include validation, because if your model is giving wrong accuracy, wrong results, you will not use it. You need to use different one or different parameters. So after this phase, you are done, almost done. You have the data clean, you have the output. Now you should tell your story. You should communicate your story for technical and non-technical people. So you cannot say a so technical model explanation to non-technical. And maybe after this phase, you may go back to your problem. And if you see, I put many loops, because at each phase, you may go back to the one before. For example, a wrong output may be a wrong exploration. So you should go back to your data, look into your data, maybe get more data and repeat it. But it doesn't mean that whenever you are done with your project, you may go back to the first, but it happens sometimes. So after knowing the process of data science, we can imagine where data science can be used. Like, data science can be used everywhere. I put some of the examples, like we have social media, connecting people. Like if you have Facebook, you always have suggested friends. It uses data science to recommend them. To see your friends, what friends they have, what's the connection, what's the profiles. And internet, like Google Engine search, to know what they should give you in your research. Also in industries, for example, if they want to know how much the machine will need maintenance, they don't want their clients to get a wrong machine or a machine that will fail always. Also in marketing, like if you purchase an item online, for example in Amazon, you are getting like this product can be bought with this product. It's using recommendation system in data science, and we will talk about this part after. Also in health, like for example, now we have corona. Many people try to predict spreading of corona according to the patient's health and according to country, and that was data science. Also in finance, like the bank don't want your money to be stolen as fraud. So it used data science to also do fraud detection. So after knowing what is data science, where it's used, you can now imagine how much data do we have? Do we really have that big data? And the answer is yes. Like I have here very small examples. We have many more. Like Google Engine is collecting data, Facebook, YouTube, Netflix is when you enter any website, sensors which can record each second. So you can imagine how big we have data. And for 2020, it's like 40 trillion gigabyte of data, but it doesn't mean that all data can be used. Some data, if you don't have the problem, they are useless. So, and in this domain, it will be, if you want to use very big data, it will be big data. And we will talk about that name after this. So now we will talk into one part of data science, not part, it's common part, but is machine learning. Machine learning is from its name to make the machine learn. And if you know Wall-E movie, so he's a robot that used like 700 years to learn from humans their feelings and emotions. And then he learned how to express his emotions. That's how machine learn. It's like a baby. A baby doesn't know how to talk, how to walk. So he will look into how humans are working, how humans are interacting, and like how humans is the data itself, and he will learn. So machine is the same. So after knowing what is machine learning, we will go into what's the difference between machine learning and all that fancy names you heard about. I'm sure you heard about AI, which is artificial intelligence, deep learning, big data, and data science. So artificial intelligence is like we can imagine it, the big mother. So it is as robots, it is to make machines give the decisions themselves, to make them smart. Not like machine learning. Machine learning is to learn data, to make machine learn from data, but without giving decisions, without making them like generate new data and be smart by themselves. But it is part from AI. And also we have deep learning, which is part from machine learning, but it's more like advanced one using neural network. And if you have huge data, you are like more likely deep learning, not machine learning. And then we have data science. It's like common between all, but it has something more. And if we go back to the process of data science, we look into data processing and exploration, which is not included in AI or machine learning or deep learning. So exploring your data, analyzing your data is the one that's not in AI, machine learning, deep learning. But data science include machine learning techniques, which is the model phase. Also, if we have very big data, you need big data, that's the name. And this part use some techniques like Hadoop, Spark. I'm not sure if you heard about them, if you are a computer scientist, programmer. So that's why we need computer science skills. After this, we will go into machine learning techniques, which are supervised learning, unsupervised learning, semi-supervised. And you can like assume what the name means. Starting with supervised learning, for example, you have basket of apples. You are giving the machine that basket and saying those are apples. So the machine will look why like the common feature between them, what makes apples special. And if you give it back an apple, it will know it's an apple. And that's like your teacher giving you like theories and you have to apply it after. It's supervised. So one phase of supervised learning is classification. You need to know what categories for the machine. Like if you have male, female, dog, cat, for example, here we have orange, apple, and the machine will classify it into 2 categories or multi-categories. For example, here it will plot the features that make orange and apple difference. For example, apple is orange and the shape is different from orange is orange, sorry, and it's not like apples, it's red or green. So it will do that difference, but it needs to know what categories. Like if it is orange apple 01, and we have like unique categories. And some of the techniques for classification is naive Bayes, decision tree, logistic regression, support vector machine. I'm not to talk about those techniques because it depends on your problem, where to solve, to use them, because some of them I didn't use before because it's not like needed, but sometimes you need to read about them, maybe research or to practice about them. So now we will go into Vice, but I'm not sure of the category. It's not 0, 1, 2. It's a continuous value, which is regression, and we can name it prediction phase. Here, for example, you have to sell houses. You have data about houses, a place, number of bedrooms, year of construction, size, and price. For example, a house in Eindhoven with 2 bedrooms constructed in 1990, size 70, is bought for 280,000 euro. And you have all that data. And now the machine task is to predict if you have a new house in Den Bosch with 1 bedroom and constructed in 1995, 30-meter square, to predict what's the price for it. And what the machine really do, like it will look into your data, it will look your data, see where's like common between Den Bosch, house, and others to predict the price. It can be like -1 or +1, but estimated price. And some of the techniques for it, learning a linear regression, decision trees, support vector regression. So now after knowing the supervised, we have classification regression, we will go into unsupervised. So here, unsupervised, okay, we have a teacher, but a teacher that is not telling you everything. Like here, you are giving it basket of fruits without telling what is what, who are the same, who are not. As a machine will work for it, will look what is the common features, common patterns between them. Like the apples, it will see like those are red, common shape. So I will put them one basket. Same for banana and mango. So it will cluster them like cluster 1, 2, 3 without knowing its label. It will not say that apple or banana or mango. It will only like, okay, I learned this without like a teacher telling me. And if the teacher do tell some of the fruits, like for example, I give it basket of fruit telling that those are apples, but the rest I didn't say, it would be semi-supervised, as if like cheating with the machine, give it some info. And one of the techniques for unsupervised is clustering. So we saw there like banana, apple, mango were clustered. And here, for example, if I have feedbacks comment like text, I have comments like it was nice, I'm happy, or it doesn't meet my requirements. So the machine will look into the words that are common comments, and it will cluster them. Like the happy comments will be clustered in one cluster, sad one, neutral one. So it will be like text mining technique used to do clustering. So sometimes you will use 2 techniques or more. And some techniques for clustering itself, K-means, spectral clustering, DB scan. After it, we have anomaly detection. Like we said before, we need to know what outlier, not only to remove, to detect it. For example, here we have fish, same colors except one, which is red. All moving same except one. That's an anomaly. Another example, if you think of your bank, you are using it, for example, once a week. Suddenly you are using it every day a week. So that's an abnormal pattern. Machine learning will detect it. We see that that user is using different pattern, so it will report fraud detection. That's how banks will report fraud detection. And also they use other techniques like text mining, but for patterns, it will use this one. And then we have product recommendation, like the one in Netflix, for example. You usually see, because you watch this one, it's recommended to watch this one, or according to your preference. So one type of recommendation is using similar users. For example, I have a girl and a boy. Both of them have same profile. They are sharing same interests, like they like comedy movies or action movies, and both are watching like some common movies. So if a girl watches a movie, it will be recommended to the guy. That's how recommendation system work. So it will connect very big connection and data from users, what users purchasing or watching to do recommendation. So that part and for data science and machine learning. And if you have any question on that part, please write it in the chat. And at the end, I will answer it. Now we will go into case studies. And for case studies, when I start with the problem, I will give time to you to think how you will do it if you are a data scientist, and what did you understand from the problem. So first case study is from Efteling. Efteling is a park in Netherlands. It's like Disney. It has some attractions, games for children. So the question was to visualize the guest crowdness, to know where is more crowded during the day. Also to profile guests, like what do they prefer? If they prefer like expensive restaurants or fine restaurants, and what attractions they are visiting. Also, if they are a bigger group or like just one or two. And also, we were asked to do potential new restaurant location, where to build the new restaurant, because you need to predicted or estimated. You don't want to lose your profit or the money you put for a restaurant. So that was the question. I will go into the data, and then I will give 1 minute if you want to share what how you will go into it. So as input data, we have guests. Like if you are a visitor in Efteling, you need to download an application which will track your location from the beginning when you enter Efteling and when you are out of Efteling, to know where you are going exactly, to which attraction, which restaurant. And then I have a restaurant location, which is like, where's the restaurant? What category? Is it expensive or not? And attraction location also, survey, restaurant sales. And for guest location, I have only GPS coordinates. I don't know where the user, if he go to restaurant or attraction, or he was just walking. That's from the data. So now I will give a bit of time if you can share, like, what did you understand? What will be like some of data exploration part you will do, and what you will do.
Feel free to unmute yourself and share your findings with us.
Okay, so I will continue with data pre-processing. So first we have to clean the data, because the data was so big, like 4 million locations. But after removing some duplicates, like for example, at 1 p.m. you have for the same user 2 different coordinates or same coordinates, you have to remove it. So we end up with 300,000 locations. And we also did for the surveys, because they were JSON parsing and we need to be able to read it in the Python code. So we did parsing for it to get only what we need. We only need like group size, ages, country to know the guest profiling. Then we did data merging. I will not go so depth in those parts. Like we have the survey, I merged it with guest location. Also data merging for between restaurant location and guest location. And here after it, I calculate crossing, because like if you are walking near the restaurant, I don't want that data. Like it will not mean that you are in the restaurant. If you are spending only near that restaurant for 2 minutes, it doesn't mean you enter that restaurant. So we did calculation for crossing, and we estimated the time duration for you. Like you stayed for half an hour, it means you are in the restaurant. If it is like less than 5 minutes, it doesn't mean you are there. So after it, our output was, because like the problem was to visualize. So this is part of it. It was visualizing the crowdness to help to know where like we need to put the new restaurant. So if you look into it, like you can see crowdness, you can see also restaurants, what type of restaurants, and attractions. So for example, the one into upright, okay, it's crowded, but you already have 4 restaurants, so you don't need it. But here, like you have 2 restaurants, it's crowded, and you have many attractions. So maybe it will be potential place for new restaurants. And you also have more visualization, like guest visualization, but here I didn't include it. Another case study is ASML, which is a company in the Netherlands. It creates machines. So the problem was that you have log files for each machine, but that log files machine can report on it. Also engineers, and each engineer like different shifts from 7 years, so they have different writing patterns, and the data was log files for those machines. The problem was only like to classify text between machine and human, to know which part of the log files are for humans and which part for machines, which will help them more into reporting, knowing if engineers are really reporting errors, are following by errors, or the machine itself is reporting wrong text or unclear text. So here's the problem. I will also give some time in case you want to share. And the log files are like this one.
So we have a question in the chat. Would you mind taking a look?
Yeah, sure. Okay, so the problem was like you have this log file, and you need to know which part of it, which body text is written by machine, which one is written by human. Okay, so I will continue with it. So first, as and yes, we can use classification. It's classification problem. So first we start with data exploration, which is I have very big log files. I don't need all the data. Some are like you are starting with the shift. I don't need it. I already know like engineers are writing it. I only need the body one. So I start with splitting according to one empty line or 2 empty line. It depends on the log file. So I split it like this one. So I have those as blocks. And after it, I have to label it because I need to know which block I want. Not all blocks are needed. I don't need to know like the start. I don't need to know the problem. I need to know the labeled of other because it's the body one. And I don't need to know the end. So the interested part is the one with label other because that's what the company wants. They want to know this part, if it is machine or human. So after this one, because like I will not go deeply into the code and other techniques, because it's classification and we have text, we use text mining, which is feature extraction. From the text, you will look into the pattern and features that is related to not a human or machine. It's to define pattern because it is unsupervised one. You don't know, like it's classification, okay, but you have clustering because I'm not giving it that line is machine and that line is human. So it's more into clustering. And after I did clustering, we use humans to know which one is human, which is machine. So sometimes not the machine who is like validating, you need to validate by yourself. So here, like our result was to give the company the name of the machine for each machine. We are coloring the output, like orange and green for machine, green for human. And for this one, it will help them to validate more the clustering, like because they are engineers, they know what's symptoms of machine and human, and they know how to evaluate clustering. So this one is last case study. We are done for now. So if you have any question, please write it or unmute yourself.
I have a question about the regression.
Yeah.
It's when you define a cluster, we use the k-mean clustering or something else, right?
As I hear from you, you are asking about regression, but then you ask about clustering k-means, right?
Yeah, clustering technique.
Yeah, like for this case study, I use k-means for clustering. But you can use another ones because sometimes that's okay.
But that make for each case we got n cluster that seem to be in that cluster and we take the percentage to make it closer, right?
Yeah, because clustering, it's hard to get percentage. It's hard to know which cluster. You can know from the machine, it recommend how many clusters your cluster is right or wrong.
Yeah, this is it. Thank you.
So we have some questions in the chat. Would you mind reading them out loud so that the recording, people who are attending the recording can know what the question is?
So I found a question in the chat, like who decide which type of machine learning to use? It is a data scientist. So for example, we have project, we need to search what techniques are used for this. Like if, for example, you are using for log files, we did some search like what's best techniques for log files. So it was like, for example, k-means cluster, but you can also use deep learning, which you will get from experience. And if you are a game developer, you can also use data science. Okay, so exploration includes cleaning. So anything cleaning, analyzing the data is data exploration.
Can I ask you something about the difference between knowledge system and data science, or what is the criteria to use the data science rather than knowledge-based system in our products?
What do you mean by knowledge-based system?
Knowledge-based system is set as an inference, have like it's almost like the automated system, but more with more intelligence. It's built on set of rules, have inference, and also have a kind of intelligence to relearn about the data from the input. This is the knowledge-based system that's already applied in several companies in my country, but unfortunately we don't find the criteria to improve it to artificial intelligence. Not to stuck with rules, make some several data exploration.
Yeah, I get you. So it is like it has some part of data science, but it's not like as you remember, like we say AI, okay, they have common part with data science, but it's not. If you want the machine to data itself, it will not be so into data science. You can help it by analyzing, by doing data exploration, but you will not help it if it will clean the data itself, will generate the data itself. So it's more into AI, this one.
Do you have any recommendation about the mathematics skills required to the data science, especially?
It will be calculus and algebra. Like you will not like all the time using mathematics, but you need to understand it. So it's only calculus. Like if you have calculus 1, I'm not sure if you are AUB, you have calculus only 1. So and algebra, because algebra is more needed.
Sounds great. Thank you for everything.
Welcome.
Okay, we will leave around 5 more minutes for questions. So if you'd like to ask a question, feel free to unmute yourself or send it on the chat. We will be answering those. And if there aren't any questions, we'll be wrapping it up soon.
Hello? Can you hear me?
Yeah.
Oh, so I was just wondering, can you explain reinforcement learning and like talk about it? Like I've heard the term, yeah.
So reinforcement learning is extra technique in machine learning I didn't talk about. It's like making the machine learn from itself, not from the data. For example, if you have a game, you will say like reinforcement learning, you make it guess like how to move. If, for example, it should move right and it go left and it lose, it will learn like going left is lose. That's reinforcement. So it will learn by itself, by scoring, by giving it score for each movement.
So basically we do supervise it at first so that it knows that this is correct and this is wrong?
No, it's more into supervised. Supervised means like more into telling us from the beginning. But yeah, if you mean like at the end, yes, you need to supervise it for scoring. And it like maybe you will not do it by yourself, because like for example, if it do an action and the accuracy is like is bad, it will learn like this action is bad, so it will do by itself. So as if it's doing by itself the accuracy calculation and the action.
So it's like a self-driving car. So if it does an accident, it knows that it does something wrong.
Yes.
Okay, thank you.
Welcome.
More depends on the state pattern, right?
I didn't hear you clearly.
I said the reinforced learning, it's more like a state pattern that we have to define to which state we can go into. Then we define the greatest path to keep winning. This is
Yes.
how we make it on Angry Birds.
Yeah, right.
Okay, anyone has any more questions?
Do you have any workshops and other workshops related to these subjects?
To data science? Sorry, I don't know who's the question for.
I'm sorry. Do you have any other workshops related to the same subjects?
Okay, go ahead with that. I think you can help
Okay,
with that.
so I'm not sure of Google developers, but I and my team will be doing on August some data science workshops, like starting from Python programming into NLP and image recognition.
Okay, but unfortunately, I am not from even Lebanon. I am from Palestine.
I'm not in Lebanon. I'm in Netherlands now.
That's good.
Okay, guys, so we're going to wrap up, and thank you all for attending. If you're an AUB student, please feel free to reach out to us. I know most of our attendees are not AUB students today. However, since we're turning online, we've opened the session to anyone who'd like to attend. So if you are an AUB student, please reach out. We'll add you to our WhatsApp group. And thank you very much for attending. Have a good one.
Thank you.
Thank you, Wedad.